This is a demonstration of the Radiation Alert Area Monitor. Different types of detectors are available, internal and external, both scintillation and Geiger-Müller. The unit features an easy-mount steel enclosure of compact size. The Radiation Alert is useful for room monitoring of hospitals, X-ray areas, linear accelerator areas, nuclear medicine laboratories, and general laboratory use. Other uses of the Radiation Alert include portal monitoring near doors and walkways. This model, the AM71313 Area Monitor, features an internal energy-compensated Geiger-Müller detector for beta-gamma radiation. The model number refers to the LND Geiger-Müller detector that it interfaces with. The operating range for this model is 0.1 to 1,500 milliar per hour. The response time varies automatically from 20 seconds to 2 seconds. The Radiation Alert Area Monitor features an intelligent resistive touchscreen with a large 5-digit LED display. The digits are 1.5 inches high. The unit features several adjustable warning indicators, such as low and high radiation alarms, detector failure alarm, and low battery. All of the settings are stored internally, even when the unit is powered off. A DB-9 serial connection is included, which can trigger up to 3 relays for remote alert options. Options sold separately include external strobe and horn. The area monitor can communicate with a PC using the included USB and Ethernet connections. The included free software server displays a histogram of collected data with the current count rate and the status of the connection. Data logging and data export are possible as well. We can easily connect multiple units on a network to the server. The software allows the user to edit calibration settings, units, and alarm set points on the area monitor. And an exciting innovation, alerts can be sent now via email and SMS texting. In the event that an area monitor alarm is triggered, the software will display the state of the event. The user can acknowledge the alarm remotely. Another exciting innovation, the user can now upload a floor plan schematic and place icons representing each area monitor in the network, thus providing a live graphic display of each unit location. If you are using an external detector, ensure that the unit is powered off and unplugged before connecting the detector to the area monitor. You want to avoid a dangerous electric shock. To start, make sure the cables are connected and power up. We first see the startup screen. The fast boot up takes only about 30 seconds. We are using AC power, but the unit can be powered by a rechargeable battery, which gives us about 5 hours. Now the area monitor is operational, monitoring background in counts per minute, CPM. The units can be changed easily by means of the touchscreen or remotely via the software. Other common units we can switch to include milliar per hour, millisieverts per hour, counts per second, and many others. Now we will test the alarm using a 10 microcurie cesium-137 check source. To acknowledge or silence any alarm, tap the alarm control at the lower center of the screen. Built-in indicators feature an ultra-bright strobe and an audible alarm, as you can see. The Radiation Alert Area Monitor has 2 separate screens for general operation of the unit, the main screen and the system info screen. The main screen is divided into 2 sections. The top displays the current radiation rate. The lower section displays the units used, which can be changed. I will show you how to do that in a moment. This indicates the voltages of both external power and the internal battery. This area displays alarm information and provides a control to acknowledge or silence any alarms. And here is the system control. Pressing the system control will open the system information screen. The upper right corner displays the current radiation rate. The rest of the screen displays several key system parameters: area monitor name and serial number, detector type and serial number, calibration date, gamma sensitivity, dead time, alarm set points, and IP address. There are 3 types of alarms: low, high, and failure. The default settings in CPM for these alarms are 3000 CPM for the high alarm, 1000 CPM for the low alarm, and 1 CPM for the failure alarm. The low alarm set point is a cautionary warning. The high alarm set point is a critical warning. Fail could mean that the high voltage has failed, the detector has failed, or has been disconnected. The fail alarm is activated when readings fall below the set point. Recommended alarm set points can vary with different models and different applications. Please note, for this demonstration, we temporarily set the low alarm to 100 CPM for display purposes only. I now want to show you how to change some calibration settings via the touchscreen. To enter the calibration settings screen, use the included pin or a paperclip to press the recessed button on the bottom of the area monitor. This will summon the Enter Passkey screen to display. Enter your passkey and select the Set button. From the calibration settings screen, let's have a look at the Set Base Unit screen. The base unit sets the units of measurement that will be used for the area monitor display and the alarm set points. In this example, we will change the units from CPM to milliar per hour. First, tap the radio button next to the desired base unit, and the displayed rate will be changed to the new unit. When finished, tap the back control to return to the calibration settings screen. We can see in the upper right-hand corner the area monitor is now measuring in milliar per hour. As you can see, we have a fail alarm because the alarm set point is still set to 1. Going back to calibration settings, we will now have a look at the Set Alarm Levels screen. This screen is used to edit set points of the 3 types of alarms. From calibration settings, tap the alarms control to open. The set points do not change automatically when you change units. We need to reset the alarm set points with numerical values that are appropriate for the current unit of measure, which is now milliar per hour. These values were entered previously because they apply to CPM, 3000 for high alarm, 100 for low alarm, and 1 for fail. We will now change the values to something that is appropriate for milliar per hour. First, tap the radio button next to the alarm type to be set. Use the keypad to enter the desired alarm level set point. We figure 9 milliar per hour for high alarm, 3 milliar per hour for low alarm, and 0.01 milliar per hour for fail. Setting any alarm level to 0 will disable that alarm. Press the back control if you want to exit and discard any changes. But for now, we press the Set control to confirm the changes and return to calibration settings. Going back, we press Done, exiting. Now the unit is monitoring background in milliar per hour with the updated alarm set points. Going back to calibration settings, we will have a quick look at the other options. High voltage. This setting controls the high voltage of the detector, set at 500 volts for this model. Threshold. The threshold sets the minimum size a detector pulse must be in units of millivolts in order to be registered as a count. This model is set at 25 millivolts. Dead time. Dead time is used to correct count rates for pulses that are missed due to pileup or from gas recombination time. Cal constant. The calibration constant is a conversion factor used to convert the detector's count rate into units of exposure or dose rate. The Set Alarm Indicators screen. This is used to set which annunciators are associated with the 3 alarms. The attached relay section refers to the internal relay settings. Tap the associated radio buttons to assign up to 3 external attachments with the various alarm functions, although we have no attachments connected in this demo. This section controls the strobe for each alarm. We can turn the strobe on or off. This section controls the siren for each alarm. Set the siren to yes to sound fully. If you set it to an intermittent pattern, the siren sounds 1 second on and 1 second off. And this disables it. Communications. These are the settings which allow the area monitor to communicate with the PC. This IP address refers to the connected PC. Calibration date. Setting the date is self-explanatory, but make sure you follow the setup and calibration sequence detailed in the manual. As we mentioned earlier, calibration settings can be accessed from the software as well. The intuitive software is user-friendly, but a detailed operation manual is available for reference. Other models of the Radiation Alert Area Monitor are available with different ranges. If the radiation alert is equipped with a scintillation detector, it will measure down to the micro-R level. The model number refers to the size of the sodium iodide scintillation crystal, 1 inch by 1 inch, 2 inch by 2 inch crystals respectively. Cesium iodide scintillation detectors are available as well. Some users prefer cesium iodide because it is less hygroscopic than sodium iodide. Cesium iodide, with a higher atomic number, is more dense and rugged. For higher levels of radiation, the radiation alert is equipped with Geiger-Müller detectors offering the following dose ranges up to 16,000 milliAR per hour. The model we looked at today was the AM71313. For both types of area monitors, please specify whether you prefer an internal or an external detector upon ordering. An optional protective wall mount enclosure is available for external scintillation probes. Custom probe configurations are possible if the user has another preference. Some precautions. Never touch the area monitor or the detector to a radioactive surface. You will contaminate the instrument. The area monitor is for indoor use only. Do not expose the area monitor to water or moisture. Water will damage the circuitry. The instrument may not operate properly near high-energy radio waves, microwaves, and electromagnetic field. Do not connect or disconnect a probe while the area monitor is powered on or plugged in. I hope you enjoyed watching our demonstration. Listed in the video description are website links to specifications, options, and ordering.